Hey everybody, this is Nick Christian with Caterpillar Global Dealer Learning. We're here in the Peoria Learning Center, and today we're going to be talking about pull-up voltage. So we're going to talk about pull-up voltage today. Pull-up voltage is something that maybe some of you haven't heard of, or maybe you've heard a little bit about it, but you don't quite understand what it is. It's actually a really important aspect of troubleshooting and being aware of it and knowing how the ECM uses it in order to trigger our -3 voltage above normal and -4 voltage below normal diagnostic codes. So what we've got here is a pretty simple example here. So we've got our sensor, we've got our wiring harness, and we've got the ECM. So some of the different aspects that we see here, we've got the 5-volt supply voltage that comes from the ECM that powers the sensor. We've got the ground or return from the ECM that also comes out to the sensor. And then we've got an analog input wire, again, from the sensor as an input into the ECM. So an analog input. If we think about things that we've talked about in previous videos, an analog input we know should be a 0 to 5 volt input, but we don't use that full 0 to 5 volt range. We use kind of somewhere in the middle. So 0.5 to 4.5 is pretty typical that we'll see for an active analog sensor. That voltage that we see, we would kind of call that the happy range of the ECM. As long as the ECM is reading, here, somewhere between 0.5 and 4.5, it knows that that's a good signal. Inside the ECM here, we have a signal sensing device that is basically going to read the voltage coming from the sensor. So in typical case here, this might be reading, say, 3 volts, right? That would be the voltage coming from the sensor. The signal sensing element inside the ECM reads 3 volts. That 3 volts gets reported out to the processor then converts that to a temperature or pressure or whatever it is that we're reading, okay? So that's under normal circumstances. Now, when we start to introduce the pull-up circuit into here, just so we understand what's happening here, inside the ECM we have a separate 6.5 volts in this example. Now, pull-up voltage values are gonna vary between different ECMs and different applications. Here we're seeing 6.5 volts, it could be 10 volts, could be 11 volts, could be 12 volts. Lots of different pull-up voltage values that we're gonna see out there, again, based on different ECMs or different applications. So don't get too caught up on this, it has to be 6.5 volts. We're just using that as an example here. So what happens here? This pull-up voltage, again, 6.5 from the ECM, and then we have a pull-up resistor inside here. This is typically a very high resistance value resistor. And so what happens is when this pull-up voltage here, you'll notice it is tied into the same circuit where the signal sensing device is reading the voltage from the ECM. So if you're asking yourself, well, if I've got 3 volts coming this direction from the sensor, and I've got 6.5 volts coming this direction from the pull-up circuit, why does my signal sensing device read 3.5 volts? Well, under normal conditions, this voltage coming from the sensor, it's a relatively low current. It's like milliamps worth of current, right? So it's 3 volts with very low milliamps worth of current. This voltage, 6.5 volts, even though it's a higher voltage, it's like microamps worth of current. So when everything is hooked up and working correctly, this voltage coming from the sensor, even though it's a lower voltage than what the 6.5 is, it essentially bulldozes, right, this 6.5 volts, and my signal sensing device here is going to read the 3 volts coming from the sensor. So let's go through a scenario when we have an open circuit condition and how the pull-up circuit voltage actually applies to this. So we've got our sensor here. Our sensor is outputting 3 volts, let's say, and the signal sensing device is reading that, okay? We know that this is basically holding back my pull-up voltage at this point. So now if I have an open circuit, right, so I get a cut in the wire, right, now what happens? This voltage that was coming from the sensor is obviously no longer getting to the ECM. So my signal sensing device is no longer reading the 3 volts that was coming from my sensor. What is it reading then? Now if we look at the pull-up voltage here, this 6.5 volts through this resistor, nothing's holding it back anymore. And so what we end up with is open circuit voltage here. Now the signal sensing device, it's really only reading voltage, it's not technically part of the circuit here. And so if we think about this 6.5 volts now is able to freely go out here. Now it is open circuit voltage, So this 6.5 volts with this pull-up resistor here, there isn't a voltage drop here, right? So in order to have a voltage drop, we have to have two things. We have to have resistance, which we do have a resistance here. We also have to have current flow. However, because this is open circuit here, there is no current flow. So this 6.5 volts, it is present, but we don't have a voltage drop because we have no current flow. So in this example, out here at the end of this wire, right, what is the ECM going to be seeing? We're going to be seeing this 6.5 volts, and our signal sensing device is going to read that. Now, let's think about that from the ECM's perspective. If the happy range is somewhere between 0.5 and 4.5, right, and it says that's a good voltage, I can equate that to a temperature or pressure. If the ECM is now reading 6.5 volts, where does that put it? That puts it above the top range of the sensor, outside the happy range of the sensor. So if the ECM is reading now 6.5 volts, it's going to throw a -3 FMI voltage above normal. So an open circuit condition will generate a -3 voltage above normal because of the ECM is now reading this internal pull-up voltage that we have. So that is the role that pull-up voltage plays. Without the pull-up voltage circuit here, we could have an open circuit and the ECM would not be able to detect that we have a voltage high condition, and we wouldn't be able to have diagnostics. So now let's look at a scenario where we have a short circuit condition within our circuit. So again, everything's working good here. The sensor's hooked up correctly. Whatever voltage comes from the sensor signal sensing device is going to read that voltage from the sensor, send it to the processor, and we read either a temperature or pressure. Now, if we have a short circuit condition on our signal wire then, okay, how does that change everything? Now, this voltage that was coming from the sensor is shorted. It's going to take the path of least resistance, and that voltage is never going to make it to the ECM. So now what happens? This voltage that we had that was holding back the pull-up voltage, it's no longer there, okay? So the pull-up voltage now is free to flow. And if we look at it, we've got the voltage through this resistor, and now it does have a completed path to ground here. So what's gonna happen? That voltage is gonna flow out. Because we only have one load in the circuit, this one internal pull-up resistor, the 6.5 volts, how much of that voltage is going to be used or dropped by that one resistor, right? If we think about this, that voltage drop that we have now, all the 6.5 volts is going to be dropped by this one internal resistor. So if all the voltage then is dropped through this one load, what is the signal sensing device going to read? Okay, the signal sensing device is going to read 0 volts then, okay? So 6.5 volts here, we've got a resistor. So basically this is reading this 0 volts, it's reading electrically the same point as what this ground reference is here. So if the ECM is reading 0 volts, okay, let's think about, again, the happy range of the sensor is 0.5 to 4.5. If it's reading 0 volts, now it's reading a voltage below normal condition. And in this case, we're going to trigger a -4 FMI code, again, voltage below normal. So the pull-up voltage circuit allows us to detect that problem. So we've looked at some of the aspects of the pull-up circuit and what all's going on inside the ECM. So let's look at that out here on an engine now. So we've got a C15 on-highway truck engine here that we can see this on. And so if we look at this here, I'm going to go ahead and we're going to read some voltages here. So I'm going to go into a ground here, and then over here I'm going to spoon into, we've got one of our analog sensors on this pink wire here. And if we look right now with key on engine off, we're reading 1.2 volts. So that's within the happy range of the sensor. And right now we don't have any active diagnostic codes. So this is a natural state of the sensor, the ECM working together to get a voltage and then output a reading, okay? So what happens if I were to go out and create an open circuit condition? So we're gonna come down here and we're gonna remove this wire. All right, so we've created an open circuit condition now at the ECM. So the pin at the ECM, as we talked about in the classroom, now there's nothing holding that pull-up voltage within the ECM back like what we had at the end of the sensor wire here. So what we should be seeing here, if we spoon into the pin directly at the ECM, and look what we're seeing, 6.5 volts. Where is this 6.5 volts coming from? That is coming from the pull-up circuit within the ECM. So where this can get a little confusing, if you're not aware of this, you should know if that's an analog signal, it's a 0 to 5 volt signal. So the ECM in this point, if I'm measuring this and I see 6.5 volts out of a 0 to 5 volt input, yeah, that can be a little confusing if you're not aware of the pull-up voltage and what its role in the whole circuit is. So it can, if you're not aware of that, it can potentially lead to misdiagnosing the ECM because, yeah, 6.5 volts out of a 0 to 5 volt input doesn't make a lot of sense until you're aware of the pull-up voltage and its role in the circuit. All right, so let's take that a step out. We just saw the 6.5 volts on open circuit condition down at the ECM. So if we go out to our sensor, you know, here again, we're seeing about 1.3 volts with the sensor connected up. So if I were to disconnect the sensor, get it out of the equation altogether, all right, so I've just created an open circuit condition, and what do we see? On the signal wire now, right, we're seeing 6.5 volts. Where's that 6.5 volts coming from? It is coming from the pull-up circuit within the ECM. So even out here at the end of the harness, with the sensor disconnected, once I remove that voltage that the sensor was sending to the ECM, the pull-up voltage is free to flow out, and we see that 6.5 volts. So this is what I should expect to see, is at the end of the harness on an open circuit condition, that pull-up voltage coming out of the ECM, I should be able to see that with my meter. So be aware of it, understand why it's there, understand what it is that you're seeing, and that just because I'm seeing 6.5 volts on a wire that's not connected to the sensor, right? Keep in mind that's coming from the ECM, so you don't have any excessive resistance or a short or anything like that in the harness. Seeing the pull-up voltage at open circuit condition is what you should expect to see. One more thing to remember on pull-up voltage values, okay? So here we're seeing the 6.5 volts. 6.5 is kind of a typical voltage that you'll see coming from the pull-up circuit, but it's not always going to be 6.5 volts. Different ECMs, different applications may have and will have different pull-up values. So, you know, here we're seeing 6.5. I've seen pull-up voltages of 8 volts, 11 volts, 12 volts, 13.5 volts is another popular one that we see on like some A4 ECM. So just keep in mind that specific voltage, you're not always looking for 6.5. Now, the voltage will be more than the top value of the sensor. So if it's an analog sensor, which is where we find these pull-up circuits within the ECM, that voltage will be more than 5 volts. But again, you may see 6.5, you may see 8, 10, 11, 13.5. All that matters is that the ECM is reading voltage above normal. So again, normal range of that 0.5 to 4.5. It doesn't matter what the pull-up voltage is. As long as the ECM sees more than the top range of the sensor, it's going to throw that -3 voltage above normal code. And that's what we're after. That's how the ECM uses it to figure out diagnostics. All right, everybody, thanks for joining me on this episode of Electronics. I hope you got some good information here about pull-up voltage and have a better awareness and understanding of it and how the ECM is using it to diagnose circuits. So, as always, if you want to come to one of our classes and learn more about this and put this into practice, doing some labs and learning even more about it, you can always go out to our DPC website right here. And then once you get there, there's a search function. You can look for this class right here, our electronics troubleshooting course. Once you've come for that, you can then come to this class, our electronics troubleshooting 2 course. So if you take both of those classes, man, you're really gonna have a lot of fun doing a lot of different troubleshooting, learning a whole bunch of stuff. So thanks again for joining us. And just to remember, when you're nice to the electrons, they're always nice to you.